Okay, we're starting with domain and range in the Dixi paper, and then we're also going to move into the identifying functions paper. So first, Dixi. This is a monadic device, so in that way it can help you remember the different terms we use for domain and range. And so for the D, that stands for domain. For the R, that stands for range. So what you'll notice is these, the D and the R, will pair up. This I and this O will pair up. The X and Y will pair up. And the I and the D will pair up. But these are all the different words that we use for domain. So domain can also be referred to as the input. And if that's the input value, the range is going to be the output. You'll see that on the identifying functions notes right here. Another way that we talk about domain is our X values. These can be X values in points, they can be X values in graphs, they can be X values in tables. So if domain is our X values, the range is going to be our Y values. And lastly, this is how we first learned about domain, range, input, output, X and Y values. We actually, way back in elementary school, called them input, or not, excuse me, not input, but independent and dependent. Because the domain values are your independent values. Those are the ones that you get to pick. Your input, your X values, those are the ones that you get to pick. Your range, your output, your Y values are the dependent. So it depends on the function rule on what happens with those values. So going over to the identifying functions, remember a function is a set of ordered pairs, X and Y, in which each X is paired with only one Y coordinate. The Y's are allowed to repeat, but the X's cannot. There's a test that we use whenever there's a graph. It's called the vertical line test. And what it means is if a graph passes a vertical line, so here's my graph, whee! If it passes the vertical line test, then it is a function. If it doesn't pass the vertical line test, my graph is a circle, then it is not a function, it fails. To be a function, any vertical line in the plane can intersect the graph of the function at most once. So it doesn't have to intersect it, but the most it intersects is 1. So let's look at these 4 examples. These 4 are kind of the easiest ones to understand. Ordered pairs. Here's our ordered pairs. Here's our X values. That's -2, that's -3. Or I'm sorry, that's 3, that's 5, and that's 8. Since none of the X values repeat, that's a function. Here I have -1, I have 3, I have 3, I have 5. Since these 3's repeat, this is not a function. In a table, I identify my X's, and I look at all of these values. 0, 1, 2, 3. None of them repeat. That's a function. You see these 3's that are repeating? That's perfectly fine. It's just the X's that can't repeat. So here's my X value in my tables. I go down, 2, 2, and as soon as I see something repeat, it automatically doesn't work. Now granted, this says 2 multiple times, more than just twice, but as soon as it repeats once, it's done. The graph is what we're talking about with the vertical line test. So this is a parabola, and if you look really closely, you can even draw vertical lines. The vertical lines do not intersect more than once, so that's perfectly fine. Here with these points, there's only one right there, but there's 2 right there. There's also 2 right here. Because of these, this is not a function. It only has to happen once, but it happened twice on this one. Mapping is something that we don't really see or do a lot anymore, but it's a great way to identify whether something's not a function. And for every x value, there can only be one arrow that comes off of it. So all of these are perfectly fine. Here, that -4 goes to one spot, that -2 goes to one spot, that 0 goes to one spot, but this 3 goes here to 0 and it goes here to 3. That cannot happen. That is not a function. Symbolically, this is how it's maybe asked a lot of us on some sort of test or something like that. The easiest way to identify if this is a function or not is to type this into Desmos. If you type this into Desmos, what you'll get is a line that cuts through 4, and it looks something like this. So that would pass the vertical line test, so that one is perfectly fine. Here, you can type this into Desmos, and what it will give you, let me go ahead and switch pens so that way it's a little easier to see, is a vertical line at -2. So because of that vertical line at -2, this is not a function because it does not pass the vertical line test, because at x equals -2, you have all of these points here, 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 here. So this fails. This does not work. That works. And if you would, in your own words, go ahead and describe how you would determine if a relation is a function. If you need a sentence starter, you could say something like, a relation is a function when ... and whatever you want to say. That's it for our notes on identifying functions. And then this page on Dixi-roid. This Dixi-roid page is probably something I would want you to turn to every day when you walk into class, just to review it.